Now in exercise 6i, we're actually going back to investigate further the APs, and in particular now we're moving on to actually finding the sum of the terms, sum of a particular number of terms in an AP. The notation is nothing surprising in that if we write capital S, subscript n, then it means the sum to n terms. Sometimes, and you saw partial sums from the previous exercise, sometimes it's easier to denote the sum that you want using sigma notation, and we've looked at that. So if we had, for example, the sum of n equals 1 to 10, that would indicate the sum of the first 10 terms of a sequence. Now, as you've found from the previous example, that exercise, that can be quite tedious to have to count up. First of all, to calculate each one and then count them up. So there's a formula. Now remember me saying, when there's a formula, it's a matter of, yes, you must learn it, or realise it's on the reference sheet. And in this case, these two are. So please be aware of where they are and use them. Now, like I said, these are a shortcut. And they, of course, when we break down these formulas, they can only be used in certain instances. So, it says the sum of an arithmetic series, or the series is when you sum it, Sn is equal to n on 2, so the number of terms, bracket a plus l, where l is the last or the nth term that you're summing to, and of course we know that a is the first term. Now, this next piece of information here takes us to the second definition. You know that L is a plus n minus 1d in this case, because it is the nth term. Nth term is a plus n minus 1d. If we take that and substitute it for L, you might be able to visualise that. Or, over here I've actually shown the substitution for L and gathered together the like terms, and you come up with the second formula. Now, what's the advantage of this second formula? Well, it doesn't rely on knowing the last term. It relies on obviously knowing the number of terms, the first term, and the common difference. What's the advantage of the first format? Well, we don't need to know the common difference. The only aspects of this formula for getting the sum is the number of terms, the first term, and the last term. Now just remember, these formulas are given on the reference sheet, so you're expected to use that. There's no excuse for anyone getting these formulas wrong. I think it's very good practice that when you do any of these questions, you identify the information in the question before you start to do any calculations. Remember me saying in class, it's like we're going to squeeze the last little bit of juice out of the orange. We're squeezing it, we're looking at this question, and we're squeezing out every little bit of information we can possibly get out of the question. So it's saying, consider this series, 100, 94, 88, 82, and find the sum to 10 terms. So, what pieces of information do we have? And here, see I have, remember, identify A, N, and in this case D. Well, you know, really we should be able to think about what we've got and what we can get out of it. Really, we should be progressing far enough, or have progressed far enough, that we can do that for ourselves. So we can see, hopefully, that A is equal to 100, D is equal to -6, N is going to be 10. We've got a formula with A, D's and N in it, and that would be the second formula, which is Sn is equal to N on 2, 2A plus N minus 1D. So I think in this case we would use this formula. So you can see there I've subbed in and I've gone to the calculator and I've got the answer 730. I guess if you had time and you really wanted to check, you could write out, you've got 4 terms there, you could just keep writing out the next 6 terms and then you could sit down and add them all. But like I said, that's only doable to a certain extent. There's going to be times when you're adding up so many terms that it's not going to be a viable option to even consider writing out each term and adding it. I think you'll be right to do 6i.